What up, dudes? Now we're going to be investigating the x squared plus c. So when we're investigating the ax squared plus c up here, we're going to consider a to be 1 because we can't let a be 0. If a were 0, then we're no longer dealing with a parabola. We're dealing with a linear function. But in this case, we're assuming that a is always going to be 1, and let's mess with the c. Let's figure out what happens when we change that number. So if my function is defined as g of x is equal to x squared plus 3, and I want to figure out what g of negative 2 is, that's simply negative 2 squared plus 3, which is also known as 4 plus 3, which is also known as 7. So this would be 7. G of negative 1, that would be negative 1 squared, which is 1, plus 3, which is 4, so that would be 4. G of 0, that would be 0 squared, which is 0, but then you add 3, so that would be 3. And then this would be 4 and 7. So if I were to graph that, it would go at 0, I'll have y equals 3. At x equals 1, I'll have y equals 4, negative 4. Or I mean positive 4 at x equals negative 1, and then at x equals positive 2, I'll go 4, 5, 6, 7, so up here, and I'll go 4, 5, 6, 7 up here, and I draw that graph and I look like this. Now, what can you tell me about how that graph looks compared to the other one? In fact, that's such an ugly graph that I'm going to go over to the computer to say, hey, can you graph something for me? Because I graph ugly things. I don't graph ugly things, the graphs that I have come out ugly. Alright, here we go. So it was x squared plus 3. What can you tell me about the difference between the red graph and the blue graph? We'll zoom out just a little bit. And really, this red graph, the blue graph, is just the same as the red graph, only it's pushed up. And how much is it pushed up by? Well, it's pushed up by 1, 2, 3. 3 units. So that kind of tells me what that C does, is it moves the whole thing up and down. Let's take a look at this one, and I'm not even going to make the table. I'll make the table and then we'll do it, but I'll just do it in my head. If I plug in negative 1 or negative 2 over here, this would be x squared minus 1. That would be 4 minus 1, which is 3. This would be 0. This would be negative 1, 0, and 3. If I were to graph that, x squared minus 1, it basically takes my graph, my red graph, and pulls it down by 1 unit. So that kind of tells me what this C does. The C, alright, here, describe how the C value affects the graph, and how does the graph change when C is positive, when C is negative. If C is positive, it pushes it up. If C is negative, it pulls it down. That's simply it. Alright, let's go to the next part right here. There we go. Notice, okay, here we go. Let's see. Oh, I see. Okay, here's the thing. Alright. When I have y equals x squared, okay, this graph, what point is the x-intercept? Now in this case, the x-intercept is at x equals 0 because at 0, the y equals 0. At y equals 0, x equals 0 as well. If I have x equals x squared minus 1, what are my x-intercepts? In this case, we're moving beyond just having one x-intercept, and we're moving into the realm of having 2 intercepts. So I have positive 1 and negative 1. Or if I have maybe a 4 over here, this would be positive 2 and negative 2. Doesn't always end up being nice. Like for example, if I have x squared minus 2, this would be positive 1.41, negative 1.41. Your x-intercepts can also be, at what point does the graph cross the y-axis or the x-axis? And in this case, this parabola, no matter how far I zoom out, will never end up touching the x-axis. It will always go up and up and up, but it will never touch the y-axis. So in this case, if I ask you a crazy question like what are the x-intercepts of x squared plus 3, your answer is nothing. There are none. Are you crazy? You must be crazy. If I ask you what is the y-intercept, in this case your y-intercept is y equals 3. But what is the x-intercept? In this particular case, x doesn't have an intercept. So if I ask you what are the x-intercepts for a parabola, there are 3 different kinds of answers you can give me. You can give me no answer at all, which would be this case. You could give me one answer, which would probably be something like that. Or you could give me 2 answers, which would be like that. Or maybe like that. This would say, oh, hey, it crosses at 2 separate points.